In this lecture, we discuss about the determination of the rate of a chemical reaction. When a chemical reaction starts, the concentration of reactant decreases and concentration of product will be increases. During chemical reaction, reactant decreases and concentration of product increases, so it is expressed in term of the rate at which concentration changes. Rate of a reaction is equal to del C by del T. Mathematically, it is represented as del C, it stands for concentration, and del T stands for time. And its unit is moles per decimeter cube, and the unit of the time will be per second. So, unit of the rate is equal to moles per decimeter cube per second. How we measure the rate of chemical reaction? There are the different methods to measure the rate of chemical reaction. We can measure it from the graph. How? Rate of chemical reaction always decreases with the passage of time during the progress of reaction. जैसा कि हमें पता है, जब भी कोई केमिकल रिएक्शन स्टार्ट होता है तो इनिशियल कंसंट्रेशन जो हमारे पास आती है रिएक्टेंट की वो बहुत ज़्यादा होती है, तो वो विद द पैसेज ऑफ टाइम चेंज होना शुरू हो जाते हैं, प्रोडक्ट बनाते हैं, तो ऑटोमेटिकली प्रोडक्ट की कंसंट्रेशन इंक्रीज़ करेगी और रिएक्टेंट डिक्रीज़ करेगा. टू डिटरमिन द रेट, द गिवन लेंथ ऑफ द टाइम graph plotted between time on x-axis and concentration of the reactant on y-axis. Here is the example. Let's consider the decomposition of hydrogen iodide to hydrogen gas and iodine gas at 508 degrees Celsius. Concentration change for 50 seconds is just 0.0248 moles per decimeter cube per second, but at 300 to 350 seconds it will be decreases to 0.031 moles per decimeter cube. जब हमारे पास टाइम जो था 50 सेकंड था तो हमारे पास कंसंट्रेशन ये थी. जब टाइम गुजरता गया, जैसा 350 तक गया, तो हमारे पास कंसंट्रेशन जो थी वो डिक्रीज़ हो गई थी रिएक्टेंट की. सो greater the slope of curve near the start of the reaction and greater the rate of reaction. Rate of reaction from slope, हम रेट ऑफ रिएक्शन जो है वो स्लोप से भी मेजर कर सकते हैं. क्या करना होगा हमें? वी हैव टू ड्रॉ द टेंजेंट एट 100 सेकेंड ऑन द कर्व एंड मेजर द स्लोप. सो दिस स्लोप शोज द रेट ऑफ रिएक्शन एट दैट पॉइंट. आफ्टर 100 सेकेंड ट्राइंगल ए बी सी राइट एंगल ट्राइंगल होगी जो हमारे पास बनेगी कंप्लीटेड विद टेंजेंट. टेंजेंट जो था वो हमारे पास एज अ हाइपोटेन्यूज जो है हम उसको ड्रॉ करते हैं. ग्राफ शोज दैट in 110 seconds the change in concentration is 0.027 moles per decimeter cube. यही वैल्यू जब हम अपने फॉर्मूला में पुट करेंगे तो हमारे पास स्लोप की वैल्यू आ जाएगी. स्लोप इज इक्वल टू concentration 0.027 moles per decimeter cube and time will be 110 second and answer will be 2.5 into 10 raised to power 4 moles per decimeter cube per second. It shows the reaction rate. Here we discuss some physical methods to measure the rate of reaction. Physical methods, spectroscopy, electrical conductivity, dielectric method and refractometric method, and last will be optical rotation method. In spectroscopy, different spectroscopy methods are used. NMR spectroscopy and IR, UV, visible spectroscopy. It is used to measure the rate of reaction in those compounds which absorb the radiations. From the length of these absorbed radiations, we measure the rate of a chemical reaction. In electrical conductivity, the ions can be studied by electrical conductivity method. The conductivity of such solution depends upon the rate of change of concentration of the reacting ions formed during a chemical reaction. So, the conductivity will be proportional to the rate of change in the concentration of the such ions. In dielectric method, In dielectric method, this method is useful for those compounds which involve small volume change in the solution. The volume change is directly proportional to the extent of the reaction. In refractometric method, it is applicable to the reaction in the solutions where there are changes in the refractive index of the substance taking part in the chemical reaction. ये उन सब्सटेंस के लिए होता है जिसमें हमारे पास जो कंपाउंड है, सब्सटेंस है, रिफ्रैक्टिव इंडेक्स चेंज करता हो. Next and last will be optical rotation method. This method is applicable to only those reactions in which any one of the reactant or product is optically active. Optically active substance rotate the plane polarized light. The extent of rotation determines the concentration of optically substance. If any of the species in the reaction mixture is optically active, then this method can be used and followed to find out the rate of chemical reaction. Now we discuss the chemical method, the method which is used to change or analyze the reactant or product chemically. In this method, concentration is measured by titration. Acid-base titration, redox titration at regular time interval, hydrolysis of ethyl acetate. Ethyl acetate react with the water in the presence of catalyst and change into acetic acid plus ethanol. Sample draw from the reaction solution at regular time interval and amount of acetic acid produced at different time interval is noted by acid-base titration. जब भी हम कोई केमिकल रिएक्शन स्टार्ट करते हैं, जैसे कि एथाइल एसीटेट ने जब वाटर के साथ रिएक्ट किया तो हमारे पास एसिटिक एसिड बना, तो हम सैम्पल में से थोड़ा सा सॉल्यूशन में से थोड़ा सा सैम्पल लेंगे और उसकी टाइट्रेशन करेंगे और हमें पता चल जाएगा कि हमारे पास कौन सा कंपाउंड बना है. फिर थोड़ी देर बाद हम दोबारा सैम्पल में से थोड़ा सा सॉल्यूशन में से सैम्पल लेंगे और अगेन उसकी टाइट्रेशन करेंगे. देन वी नो अबाउट द रेट ऑफ केमिकल रिएक्शन के क्या रेट चल रहा है हमारी रिएक्शन का. So, after titration graph is plotted between the time on x-axis and concentration of acetic acid on y-axis. The slope of the curve tells us about the rate of chemical reaction. At first, reaction rate is high but decreases with the passage of time. When curve horizontal, then rate becomes 0.